So now at long last, we're at the very end of our discussion of the Java Executor Framework. So we're going to spend just a few minutes kind of wrapping up, giving you a perspective on all the pieces. As you might realize, if you go back and take a look at all the different topics we've covered in this course, you'll see that the Executor Framework occupied quite a large amount of time. It's got dozens of classes and interfaces in it, and it provides a number of very interesting different sort of sub-frameworks, including things that work with the executor interface, things that work with the executor service interface, things that work with the completion service interface, things that work with the scheduled executor service interface, and all the other stuff that's needed to make all that work. So callable, runnable, future, future task, all those good things. So let's kind of put all the pieces together so you can see how it all fits together at a high level. So at a high level, the main goal of the Java Executor Framework is to decouple the creation and management of threads, most commonly pools of threads, though it doesn't have to be pools of threads, but most commonly pools of threads, which are decoupled and separated from the application logic. So the application logic is defined in terms of these tasks, and the underlying Executor Framework interfaces and classes then make it possible to run those tasks in different types of thread pools or different types of thread configurations. And it's really easy to switch around between them. The interfaces are done in such a way where it's pretty straightforward to plug and play the different mechanisms, the different sub-frameworks, if you will, that implement the different thread pools. And we've seen a bunch of examples of that. So if you go back and you watch the different case studies where we've used the Prime Checker app, you'll see fixed thread pool, cache thread pool, work stealing pool, and so on. And in all the cases, we could kind of plug and play the different types of pools, and the rest of the application remain more or less the same. The Executor Framework actually forms a very large part of the overall Java util concurrent package. So if you go out and take a look at the package for Java util concurrent, you'll see that there's a lot of classes that contribute one way or another to the Executor Framework. And I've shown a bunch of them here. There's even more, but these are some of the common ones. So we have things like the executor interface, which is the kind of the core of everything. We've got executor service and executor completion service and abstract executor service and fork join pool and yada, yada, yada. It goes on and on and on. So there's lots of things to learn. This can appear daunting at first, but once you see the programming interfaces, you realize a lot of this stuff just exists to kind of hold the different implementation variants together and to do them in a way that can leverage and maximize internal reuse of the different facilities in order to carry out the semantics that are provided by these different types of thread pools. Something else that's interesting, and we'll talk more about this in upcoming lessons, is the fact that the framework applies many patterns from the pattern-oriented software architecture book series, which I was co-author on a number of those books, as well as the famous Gang of Four design pattern series. And we'll talk more about those patterns here shortly, but you'll see there's lots of patterns that are implemented, like command processor and active object and thread-specific storage and half sync, half async, and monitor object, and all these good things. And so it's kind of reassuring to know that these patterns that we read about and study in some of the courses at Vanderbilt are actually applied in very mission-critical contexts like the core Java concurrency utilities. Gives you a good feeling that this stuff isn't just made up out of thin air. Interestingly, there's surprisingly few Java synchronizers that are used in the implementation of the Java Executor Framework. You might think, well, gosh, there's a lot of threading going on here. There should be a whole bunch of synchronizers. Well, there's actually very few of them. And the reason for this is that the underlying mechanisms are largely based on message passing. So the things like the blocking queues, the linked blocking queue we talked about, a lot of the processing and the coordination between threads is done by message passing. Now, of course, if you look in the bowels of the message passing mechanisms like linked blocking queue, which we will do when we get into the patterns discussion here fairly shortly, you'll see that those mechanisms use some of the Java synchronizers and the shared object synchronizers, things like reentrant lock and condition object and so on. But other than that, there's really very little use of that. And almost everything else is done by passing messages back and forth. So just a side note, it's not particularly, it doesn't mean that those shared object synchronizers aren't important. It just means that they have been layered and integrated behind a message passing facade. The Executor Framework, if you really think about it broadly, it provides an imperative model of concurrent object-oriented programming, which of course has been the main focus of this course. So you can create these task objects, which are typically either runnables or callables, but they're good old objects. You submit them, or you execute them, or you invoke whatever the methods are in order to get them into the appropriate type of thread pool that's you've selected, either cached or fixed or work stealing and so on. And then those objects are either queued or not queued and run by threads in the pool. And then the results are delivered or not delivered, depending on the semantics of what you've chosen, through various means. But the overall philosophy behind this framework is the concept of objects and allowing those objects to run concurrently in a pool of threads. In contrast, the Java parallel streams and completable futures frameworks provide a declarative model of parallel functional programming. So this model is fundamentally different in many ways than the concurrent object-oriented model that the Executor Framework provides. And quite frankly, if you're doing modern development, you're more likely to use either parallel streams or completable futures, or, as increasingly the case, something like the reactive streams model, which we've talked just a little tiny bit about here. These topics are all, for the most part, outside the scope of this class. If we have some time at the very end, we might just do a little bit of a teaser for some of this stuff. But if you want to learn more about these declarative approaches to computing with multi-cores and parallel computing and so on, then I highly recommend you take the course that I'll offer again in the fall. And that's the CS X253 course, 3 253 or 5 253, depending whether you take it as a graduate student or an undergraduate student, respectively. And that's where we really go into great detail about the parallel processing facilities through parallel streams, through completable futures, through reactive streams, and RxJava or Project Reactor. So if you have a chance to take that course, if you're not graduating, you should take a shot at trying to take that course before you leave Vanderbilt. I think you'll like it because it really complements a lot of the things we cover in this class, but for my money, really gets you into the brave new world of functional programming and reactive programming, which is kind of taking the world by storm these days. So good thing to learn about, but unfortunately, we don't have enough time to do justice to it here. I'm just giving you a little preview of coming attractions. So that's the end of our overview, kind of summarizing the Java Executor Framework. For classic Java concurrent object-oriented programming, the Executor Framework is the way to go. For more modern uses, as we've outlined here, you want to go with the more modern functional and or reactive ways of writing concurrent and parallel software.